At this point, we've learned that a log, or a logarithm, is really just the inverse of an exponential function. So what we're going to do today is we're going to talk about kind of like an introduction to solving logarithmic equations. In order to do this, we need to use something that I call circle the base, run the race. And what this allows us to do is it allows us to take an equation from logarithmic form and rewrite it into exponential form so that we're able to solve it. All right, so this is how it works. When I say circle the base, run the race, what I'm going to do is I'm going to circle this base. And when I say run the race, I mean I'm going to cross the finish line. I'm going to run to the other side of the equation, and it's now going to become the base on the right-hand side of the equation. So this b is no longer the base over here. It's going to become the base to the a. It's going to become the base on the right-hand side of the equation. And what happens is when we move this base, the word log is no longer there. So I'm just going to take this c, and I'm just going to bring it right down. So it leaves me with c equals b to the a, which you could see is what we had over here. Okay, so log base b of c equals a is equivalent to c equals b to the a power. This is called logarithmic form, and this is called exponential form. All right, so what we're going to do here is we're going to practice rewriting log equations in exponential form. So what we're going to do is just circle the base, run the race. So here I'm going to circle the base and run the race. So when I do that, the word log drops off, so I could bring down my 125. And this 5 now becomes the base to the right-hand side of the equation. So it's going to become 5 to the third power. All right, and you'll notice here, I mean, there's nothing to solve. We didn't have any variables to start with. I'm just taking this log equation and rewriting it in an equivalent exponential form. And this is a true statement. 5 to the third is equal to 125. All right, let's do the same thing with number 2. So again, there's nothing to solve. There's no variables here. We're just converting it from one form into an equivalent form. All right, so to take it out of logarithmic form, we're going to circle the base and run the race. So the word log drops off, so I could bring down that 1/8, and then equals, the 2 now becomes the base on the right-hand side of the equation. So we have 1/8 equals 2 to the negative third power. And again, this is a true statement. 2 to the negative third is equal to 1/8. Okay, we're not solving anything. There's no variables, but we were just rewriting it in exponential form. All right, so let's take a look at some equations where we do have a variable to solve for. So if we take a look at number 3, it's in log form. So what we want to do is we want to change it from logarithmic form into exponential form. So I'm going to circle the base and run the race. And when we do this, the 512 drops down, and then the x becomes the base on the right-hand side of the equation. Okay, now the reason we get it into exponential form is so that we can solve it. So to solve for x, what we want to do is we want to get rid of this fractional exponent, so I'm going to just raise both sides of the equation to the reciprocal power. And the reason I do that is because when we have a power raised to another power, we're going to multiply these here. So the 3 on top cancels with the 3 on bottom. The 2 on top cancels with the 2 on the bottom, and it leaves me with just an x. Now, I mean, I know you can just take 512 and raise it to the 2/3 power and plug it in your calculator, but rather than do that, let's just practice with our exponent rules. So if you remember, if we have a fractional exponent, we do power over root. So what that means is we're going to have the cubed root of 512 to the second power. So let me write that out. The cube root of 512 to the second power. All right, so the cube root of 512 is 8. So we have 8 to the second power equals x. And 8 squared is just 64. So we wind up with x being equal to 64. Number 4 starts off the same way. We want to take it out of logarithmic form and put it into exponential form. So again, I'm just going to circle my base and run the race. So it leaves me with x equals 81 to the negative 3/4 power. All right, well, I mean, x is already all by itself on the on the left-hand side of the equation. But rather than just plugging 81 to the negative 3/4 in my calculator, let me use our exponent rules again. All right, so first thing, if you have a negative exponent, we could make that into a positive exponent by moving this whole term to the denominator of a fraction. So it becomes 1 over 81 to the positive 3/4. And then using my rule of power over root, I'm going to rewrite this as 1 over the 4th root of 81 to the 3rd power. So 1 over the 4th root of 81 to the 3rd power. Okay, well, the 4th root of 81 is 3, and 3 to the 3rd power is 27. So here, my final answer would be 1 over 27.